Want us to evaluate this integral. It's definite integral. How do we do it? Well, first I'm going to rewrite this thing. Because why? Because I don't want fractions, right? Don't like no stinking fraction. That's a big old fraction. I want to do the quotient rule backwards. That sounds awful. So instead, what I'm going to do, I'm going to rewrite this. This is the integral from 1 to 7. And then I'm going to break this up. You know, like if you have 5 plus 6 over 20, that's the same thing as 5/20 plus 6/20. Either way, it's 11/20, right? So my point is when you have two things over one number, you can break them up into two if you want to. Well, that's what I'm going to do here. I'm going to say, okay, so this is going to be 8x squared over the root of x plus 7 over the root of x dx. So I'm going to break it up. Why? Because then I can simplify it and divide it. Let me show you. So then I can say, okay, so now that's the integral from 1 to 70. This is still more rewriting. What's that going to be? This is 8x squared times x to the minus a half plus 7x to the minus a half dx. You good with that? A square root on the bottom is a negative half power, right? The negative part puts it on the bottom and the half power is the root. Same thing here. It's x to the minus half. Okay? So now I'm still rewriting. Now, minus a half is minus 0.5. So it's 2 minus 0.5. So this is 8x to the 1.5 plus 7x to the minus 0.5. Just go into decimals to make life easier. Do you see what I did there? I took this 2 power and I subtracted a half. Like $2 take away 50 cents is $1.50, right? Remember that? Those powers just add, subtract together. And so now we get this. Now, this is all just, again, rewrite. I haven't done any anti-derivatives yet. So now I'm going to do an anti. Now it's anti-time. So let's do it. So I'm going to go, okay, now that it's all nice. Anti. What's anti? Well, you take 8, take the x, you what? You add 1 to the power, that'll be 2.5, and then you divide by that 2.5. Plus, and I'll do the next part. I'll do the anti of this guy. So that can be 7x. And you're going to what? Add 1 to the power. So minus 0.5 plus 1, like minus 50 cents plus $1 plus 50 cents. And then you divide by, right? And then we're going to evaluate these things. Whoop, didn't do that correctly. Made it a little rounded. We're going to evaluate these between what, 1 and 7. 1 and 7. So that means you, first thing you do is you take that 7 and you plug it in, plug it in. So let's do it. So I'm going to get 8 over 2.5, 7 to the 2.5 plus 7 over 0.5, 7 to the 0.5, like so. And then we're going to go minus, and we're going to do the second part. And now we're going to take the 1 and we're going to plug that in. Boom and boom. So we get 8 over 2.5, 1 2 to the 2.5 plus 7 over zero point 0.5 times 1 to the 0.5. Like that. All right. So you see what we did there. Let's recap before we go to, well, let's go to decimal. Let's go to decimal now. So 8 over 2.5, 7 to the 2.5. So 8 over 2.5 times 7 to the 2.5. That's messy. 8 over 2.5 times 7 to the 2.5. 8 over 2.5, 7 to the 0.5 plus 7 over zero point 0.5 times 7 to the 0.5. 7 over zero point 0.5. 7 to the zero point 0.5 minus, like so, yeah. Okay, 7 over zero point 0.5 times 7 to the 0.5. 7 over 0.7 to the power minus, and then it's the same beginning, but it's, oh, this 1 to any power doesn't do anything. That's going to be 8 over 2.5. 8 over 2.5. If you're not sure about that, you can type it in, but I'm telling you, 1 to any power is just 1. So, right, this is just 1 to any power. This is 1, and times 1 doesn't change anything. It's just 8 over 2.5. Plus, the same thing here, 1 to any power is just 1, 7 over 0.5. There we go. Don't need to close the parentheses. 434, 69, blah, blah, blah. Is that right? 434, 69, blah, blah, blah. There it is. Okay, so again, what did we do? We took this thing, we said it's a fraction, we don't want that, we're going to rewrite a bunch of rewrite steps. That was most of the problem. So separate this. It's like separating two fractions, common denominator, just separate them. Why? Because then we can bring this up as x to the minus half for each part separately. Then we add subtract powers. 2 take away a half is 1.5, and there's just minus zero point 0.5 there. Then I was ready. So then it was in position. Then I did the anti and the anti, which is add 1 to the power, divide by 1 to the power, divide by. Then take the upper bound, plug it in there. Lower bound, plug it in there, and put a minus sign between them and go to Desmos. And so there it is. We did the definite integral.